Hi everyone. So let's talk about energy. So we have different kinds of energies. For the mechanical energies, we have kinetic energy and potential energy. And potential energy can be gravitational or elastic. And in the lab, we will be using gravitational potential energy. So I'm going to be limiting this explanation to gravitational potential energy. So when you say total energy of the system, which means basically addition of kinetic energy and potential energy you have within your system. So kinetic energy is the energy associated with the motion. So when you move, you have velocity, right? So kinetic energy is given as 1/2 mass times velocity square, and gravitational potential energy is given as mass times gravitational acceleration times the height from the ground. So GH. So whenever you add these two numbers, you get the total energy of your system. And as long as there is no friction in your system, um, this number is going to stay the same. So I'm giving kind of a roller coaster example in here. As you can see, from point 1 to point 2, the height is changing, and the velocity is going to change because, objects basically accelerate due to gravity as they fall down. So I picked up some numbers just to give you a numerical example to solve. The mass is taken to be 10 kilogram. I'm going to use G to be 10 just for mathematical convenience. And height, the first height, the position of the one is 5 meter high, and position of the 2.2 is 3 meter high. And so under the case that there is no friction from point 1 to point 2, I can calculate my total energy, the object's total energy at point 1, right? By doing 1/2 mv square plus mgh. So this is the kinetic energy, this is the potential energy. And when I do this calculation, I found this total energy to be 520 joules. And I know that if there is no friction, while the object is moving from point 1 to point 2, it's changing its kinetic energy along with its potential energy. And as you can see, the height is getting less, so it means the potential energy is going to be less. While it means potential energy is becoming less means the kinetic energy is going to become higher, which also makes sense because it's going to get accelerated from point 1 to point 2, right? But they're going to be changing in a way that they compensate each other, and the total energy is going to stay the same. So whatever between point 2 to 2, like any point, you pick any point, you do this calculation 1/2 mv squared plus mgh, you're going to get the same number, which is 520 joules, any point. So that's what energy conservation means. So now that I know the initial total energy is 520 joules, I know that the total energy is going to be 520 joules along this path at any point, including number 2. And I know the height of the number 2, so I can basically use that information to calculate velocity at point 2, right? Because I know the height. So therefore, I can calculate the potential energy at point 2, which has a height of 3. And so I basically substitute my total energy to be 520, and it is equal to total of kinetic plus potential energy, right? The kinetic is 1/2 mv squared, the velocity at point 2 squared, plus mgh for the point 2. Therefore, this is going to give me 520 is equal to, I just canceled 2 with the 10 here and got 5. 5v2 squared plus 300, so I subtracted 300 from both sides, and I got 5v2 squared is equal to 520 minus 300 is 220. And I divided both sides with 5, and take the square root of v squared is not what I'm looking for. I need to find v itself, so I take the square root of both sides, and got the v2, the velocity at point 2 to be 6.63. So it was 2 at the beginning, right? I calculated my total energy as the initial velocity to be 2 meter per second at point 1, and it became 6.63 at point 2, while its potential energy reduced from 500 to 300, its kinetic energy increased from 20 to what is that? It's like 220, I think. If you calculate it with this velocity, you would find that, I think. So at this point, I want to add one more complexity to this question. So now we have done that in the case that there is no friction between these 2 points, we can calculate the velocity at the second point given the height just by calculating the total energy and knowing the fact that it's going to be conserved, meaning that it's going to stay the same, right, here. So if I tell you there is friction from point 1 to 2, and you're going to spend 100 joule on it while this object is moving from point 1 to 2, it's going to spend 100 joule on friction due to friction. So it's friction basically causes the system to lose energy, and that loss is not really exactly like this disappearing or anything like that. This much of energy basically is going to be released to the environment as heat. So if you rub your hands, they get warm because you use the friction to create that heat. So you transfer your body energy into this heat energy. It's called loss because of the fact that that energy cannot be collected back and you cannot basically make use of it anymore. It's released to the environment as heat, and so it's unusable for you. So that's why it's called loss. So now that I know the energy is going to be lost from point 1 to 2, and I'm given the amount of energy that is going to, which is 100 joule. So I know that the total energy at the position 1 was 520 joule, right? Because I was given the initial values of velocity and height. So I still have that values to be true, which is basically 520 joule of total energy at the position 1. But I know that on the way to 200 joule of this energy is going to be spent on friction and released to the environment. So the total energy at number 2, position 2, is going to be that much less. Therefore, 520 minus 100 is going to be whatever the total energy that the object is going to have at position 2, which is 420, right? So I'm going to use that total energy to calculate my new velocity at position 2 in the case that I spent 100 joule on the friction. So 420 is going to be total energy at point 2, means that total of kinetic energy plus the potential energy again. But this time it's not equal to 520, but instead it's going to be 420. So I will do the same thing. So I'm going to subtract 300 from both sides and find that v square, in this case v2 square, is going to be equal to 24. And when you square root on both sides, you get 4.2 meter per second this time. So you can see that v2 is less than before. Previously we had 6.6, now we have 4.9. And the difference is because of the fact that potential energy was 500 at position 1, and now it's 300 at position 2. So the difference is 200 joule, right? So potential energy has dropped 200, and you expect kinetic energy to increase 200 from point 1 to 2. But in this case, because of the friction, it doesn't increase that much. It increases 100 joule less, and therefore your velocity is less in the point 2 in the case that you have friction. So I hope this helps for you to understand and be able to solve the questions in the lab. And let me know if you have more questions. Have a good day.